The application is capable of searching for multiple different stocks at the same time. It waits for them all to be loaded before populating the UI with the information. I'm sure that we can improve the user experience, and instead of waiting for all of them to finish, we'll add the data for each stock as it arrives. Let's change the mock stock service back to the real stock service. We are already querying the API for the different stock identifiers that we are searching for, and we're doing that simultaneously. There are a few changes needed to populate the data grid with the data as it arrives to the application. First, we'll need a collection, or a list, where we can dump all the data that we're getting back from the API in the asynchronous operations. For this, we'll use a concurrent bag. This is a thread-safe collection that allows you to add items from multiple different threads without worrying about data being lost on the way. If you use a normal list, you might end up having problems because you might end up trying to add data from different threads at the same time. Therefore, make sure that you're using a thread-safe collection. Next, we'll go down to the loop that starts a task that calls the API for each stock identifier. This for each loop will make sure that we start all of these queries to retrieve the stocks, pretty much at the same time. What we're also going to do now is to chain on a continuation that will run when each API call completes. Performing this API call might be rather quick. To make it a little bit more interesting, I've already added a short delay in the stock service. You'll see the task.delay that will simulate that each time we call this method, it's going to incrementally take a little bit longer. Obviously, this isn't something you'd want to ship into production, but it makes it a little bit more interesting when we are running our applications to learn about all of these patterns and principles, as it better illustrates the benefits of the changes we are about to make to the application. Each service call now has a continuation chained onto the task that represents the asynchronous operation. Inside the continuation, we are going to add the data from the result to the thread-safe collection. Let's just pick the 5 first stocks that were returned from the API. This result is available on the task that was passed into the continuation. You can grab it through the result property. Notice that there's an error. Let's return the 5 stock prices that we filtered out. Now the code further down still works and compiles. These items now need to be added to the concurrent bag. This requires us to add each item one by one, so we'll increase a for each loop and add each of them independently. This is starting to look great. For each company or stock identifier, we perform an API call. We'll then take the 5 first stocks and add that to the bag of stock prices. All that's left now is to update the UI. Previously, this was done a bit further down at the bottom of this method, but we're going to remove that because we are no longer waiting for all the API calls to finish. We'd now like to update the UI each time we're inside the continuation, because that's when we get new data. As always, when invoking the UI from an asynchronous operation, you'll have to use the dispatcher or equivalent in the UI framework that you are using. The work posted to the UI thread will ask the data grid to be updated with a copy of what's currently inside the concurrent bag. This will take all the items that are currently available in this concurrent bag and create a new array of those items, which will then be presented in the data grid. Before we run the application, if you haven't changed the timeout to more than 2 seconds, now is probably a good idea to do that. Otherwise, you will probably end up having issues. Optionally, you can remove the timeout handling completely. If you do, make sure to await the All Stocks Loading task, which is simply a reference to the task created by task.whenAll. We can search for Microsoft, Google, and a few more that we know exist in the collection of stock prices. The application is populated with Microsoft, Google, and all the other stock data as it arrives from the stock service. This here shows you the power of chaining on continuations onto multiple different tasks. This allows us to handle the result as it comes back to the application.